all, and welcome to another electrifying episode of the High Voltage Live Show. I'm your host, Willie Snyder, with Nat King Code, coming to you live from the Mile High City in Denver, Colorado. We are joined by a special guest tonight, and also we have our my awesome partner in crime over there, Bolt Online Academy, Mr. King James Stallcup, and we are joined by Mr. Mark Candells again. Awesome to have you back, sir.
Thank
we love
you.
having
Thank
you on.
Thank you.
And I've had just such great participation with the Myth of the Week. I didn't know if I told you this, James, but I actually just added 10 more to the NEC for Dummies group. So welcome in to you 10 members. I don't remember your names, but it's really awesome that our group's growing so fast.
We're getting tagged in the group.
Yes, sir. We already got people jumping in the chat in here. Welcome in. It's really awesome that we are able to bring you these myths of the week. This one was a little quirky this week. It was just because a lot of my myths come from actual comments in Facebook groups. So like people will say, hey, that's a code violation, you know?
Well, some of them are comments and some of them are just haters.
Yeah, but it's weird because with the myths, they sound weird. They sound totally weird. Like you're like, nobody could ever think that's a code violation. And then you'll get one or two comments every time that say, oh, yeah, that was in the code, you know? And so then you're like, okay, this is weird. And that's kind of how they get to be the myth, you know, is they weren't, some people think they were in the code or maybe they weren't in the code, but it's just awesome to get it out there, bust the myth and, you know, get James to bust out a little of his slides and show some of his material and stuff like that. But I don't know, the last time you were here, Mark, we weren't doing this, but we are actually doing this time. We're doing the meme of the week.
Yeah. So I'm on the show. I'm watching it every Thursday night, 8
nice.
a.m. or 8 p.m. Eastern.
Right on. But anyway, this meme of the week is actually a real one. And we were running a rack of rigid and we're staggering our couplings. And my apprentice asked me, he goes, hey, can I put a strut strap on the coupling? You know? And I was like, nah, you can't do that. It's, you know, it's not listed for that. And it's not going to, you know, I mean, more or less, it's just a spec for the place we were working at. Like, you just can't do that. It's not up to their par with their specs. But then I went to research if it's actually a code violation, and it's not. Turns out, as long as the conduit's secured, you can secure it wherever you want. And on the rigid coupling, it's securing the pipe as long as you get it securely fastened. So I was wrong, and then I decided, you know what, I'm going to make this meme about him because we're not putting a strut strap on the coupling in the place we were working at. We ended
up, as long as that coupling's properly tightened, it's now part of the conduit, so why not?
Yeah, so that's where the meme of the week comes from this week, and it's pretty funny.
Here we go.
And it was pretty much how he acted too when I came back and told him was it a code violation. He's like, yeah. And I'm like, we're not doing it. You know what I mean? I was like, it doesn't matter.
You're buying him lunch off the roach coach.
Yeah, pretty much. I've eaten my words a lot of times on the job site, but you know, that one was actually pretty funny because he was all proud about that you could strap on the coupling, but we didn't strap it on the coupling. We went cut it back and made our rack even, made it.
There you go. Nice. There go the labor units, right, James?
Oh, yeah.
Labor units.
That's sort of like, I remember one time I was working with Dad, who pretty much knows everything. And we had this publication that covered every calculation in the code. And he goes, I want you to go through and check all that. I said, all right. So I started going through it all. And and we actually teach this now, and it's one of our thumb rules. But I started noticing when I was sizing any overcurrent device, if I took it at 125% or less, I went up to the next standard size. But when I got above that percentage, I was dropping down. And I went in and asked him, I said, is this something that is common in the code that this is how we do it? And he goes, I've never really thought of it. And he goes, let me look at it. And at that time, the transformers was that way. The only place that it wasn't was when you were doing phase conversion. And 455.7A2 tells you go up to protect the conductors. And he come in there, he goes, you're right on that. He goes, we're going to start teaching that the way. So I was the apprentice.
There you go. Yeah, the junior thumb rule.
That's right, junior thumb rule.
Yeah.
Well, every day I learn from my guys, so I never say know it all, and every day you learn.
Oh yeah, and that's the whole point of this show is to kind of get everyone's feedback, kind of bounce stuff off you guys, and it's really awesome. I mean, there's stuff I've seen that you guys haven't. There's stuff you guys seen out in the field that I would just never even imagine. Like when you get into what you were talking about, James, with some of those chemical plants and mixing chemicals and upper level limits and stuff, I couldn't imagine actually calculating that, being a qualified enough engineer to actually, create an electrically safe work condition in that environment. So, that's a lot of stuff that you need to know, and everyone needs to know out in this field. And that's what we need to be doing is working electrically safe work condition, and just basically trying to make sure that safety starts with us. You know what I mean? It's like personal protective equipment. That's your last line of defense,
Sure.
So your first line of defense is your brain and being smart.
And like you said, Willie, we all learn from each other. That's why it's so important to watch a podcast like this, because you've got an opinion, James has got an opinion, your other guests have an opinion. They're all bringing something to the table. We're all learning from each other.
Sure.
Right. I agree.
It's funny that you brought up the hazardous location, because I was talking to Dad, and we're looking at taking, after we update everything, we're looking at taking, we have a chapter 21, which is actually a pretty big chapter in the design book. It covers hazardous, but it doesn't really get into how you go in and do all the classifications and how you go in and use NFPA 497 and 499. And like you were talking about mixing chemicals, upper and lower flammable limits, you got your MSG, your MIC ratios, all of that. We're actually looking at, we're going to go ahead and do a publication, and we're going to add all that in. We're going to make it 2 parts. We're going to have one for classification, and then we're going to have another that'll be installation by the National Electrical Code. And this way, people that deal in the hazardous location industry actually know how to use those other standards, because like when you get into the oil and gas, we also have stuff in there where you have to look at API 500, which is American Petroleum Institute. And if you're dealing with European stuff, then you got to take and look at API 505. So there's a lot of stuff you have to look at when you start looking at getting into hazardous locations. I like to say this, it's a whole different other animal than the rest of the code, because there's so much other stuff you have to look at when you get into that classification. So we're actually going to look at doing a publication on that.
That's great.
So so this is I'd say that's one of the most misunderstood areas of the code is classified locations. Another really misunderstood area is fire safing. And so I know when I talked to you once, Mark, you were having an issue with fire safing, and we run into it quite a bit. We're always doing like 1 hour, 2 hour walls where I'm working at. So ran into this thing for the myth of the week, and it's really funny because a lot of times you see this fire safing and it's just really messy and everything. So this whole myth kind of has a bunch of new levels that kind of come to it. And this came in one of the groups a while ago where somebody said that you can't have no more than 190-degree bend per section of pipe. So what they're saying is you have to do a 90, then you have to do another 90. Like they said you can't. They said you were actually damaging the pipe if you went more than a 90. And so we know that's horseradish. That's not true. Like this myth was really busted this week, you know what I mean? And it was not even really a valid myth, but we ran it because it was always in the comments. Well, it was interesting because I ran the myth and I thought, oh, everyone's going to see how crazy this is. And there was 1 or 2 comments where they're like, oh, wasn't that in the code? And so I'm not sure if maybe it was in the code back when they were using the hickey benders, and they maybe had something in there where you could only have so many hickey bends in one section of conduit or something weird. But I don't know. It always comes up as somebody says it was in the code at one time. So
I don't remember it.
No.
Yeah.
And I go down a lot of ways.
I guess
you just
we'll
got
have
the
to run
360-degree rule. That's it.
That's it.
Yes, sir. So I guess we'll run the myth of the week then.
Let's do
Let's
it.
do it.
It's time for Myth of the Week.
All right, so we had a really good one this week. I asked Mark Candles, I was like, hey, what should I run for my Myth of the Week? And he's like, let's go ahead and do this Shepherd's Hook one. It's in the myths. I think it's myth number 38 in NEC for Dummies. You could always go into the announcements and look at our myths, and they're all numbered. And it says like what the myth is, and they basically came from actual comments of people saying that these things are code violations. And it's kind of a little bit of an eyesore violation. I mean, it doesn't look very pretty, and I think it's actually hilarious seeing the fire saping on there. Like, I mean, that apprentice probably wore more of that fire saping home than he got on that wall, but
And he probably sweat trying to push a snake through that darn thing too.
Yeah, and that's a good point, Mark, that you probably eat up most of your bends. If you're doing 360, you're probably taking up, close to 180 on something like that. And I don't know, I'd say at least 120, 130. So, like I say, that'll significantly decrease. So basically, if you go run these bends all the time, you're going to need a box anyway. You're going to need a pull point anyway. A lot of people mention them for where you don't have access with. I can understand that. And a lot of people really appreciated it. A lot of people posted a bunch of these bends in the comments and showed how certain times you have to do this. I don't think in this case he would have had to do it, but I thought it was actually kind of funny just seeing it sitting there. And I thought, man, that guy was really proud of himself. And then the thing that's funny about the fire saping, this is really misunderstood, is basically this could actually fail on fire saping. Like, they have 9 times the amount of fire saping that you need on that penetration, but the actual penetration itself is actually the drywall, where it comes to the drywall. So that drywall where that fire saping is needs to be at least 5/8 inch thick for a 1 hour wall, or 1 1/8 thick for a 2 hour wall. And I can almost guarantee I could probably go up there and stick a screwdriver right through that. It's probably maybe 1/8 of an inch.
Well, Willie, the bottom line is you've got to follow the UL standard for that penetration.
Yes, sir.
There's a picture, there's a standard of how it's got to be done, and I'm sure the picture does not look like that.
Yeah, absolutely, Mark. And what we like to do is we like to kind of put a little bit of tape around the edges, make a nice square, kind of like carve out the drywall a little bit to make it where you're able to get in there and get a nice annular spacing. So just to make people understand a little better, when we're doing this fire saping, what we're trying to do is we're trying to get the fire saping material inside that, where that penetrates through the drywall, at least the distance of what that material is coming through. So you want the inside of that to at least be 5/8 of an inch. you don't care how much you spread around the outside. And I could almost guarantee if we did a destructive test on that, I bet you that would fail. But, that's one of the things about misunderstood codes. I would say that mostly this fire safing is probably not a good example of what would be considered good. And also, the myth is busted. Shepherd's hook is perfectly fine. There's nothing wrong with it as long as you're less than 360 degrees in your conduit run.
Okay, can I go now?
It's all you, brother.
Okay.
Sorry.
Here's where you want to go, and I just pulled out 3 for IMC, rigid metal conduit, and EMT, and they're going to tell you that the run shall not exceed 360 degrees between pull points. That's it. Doesn't say anything about one conduit, but I am going to point something out. Right before this, in each one of these sections, you'll have an A that's in there, and it's going to refer you to Chapter 9, Table 2. And this is where you're going to get into these concentric 90s, and it's going to tell you how far you go back. So like if I'm at a ½ inch, it's 4 inches. And this is where you're going to make a sweeping 90. So if you're doing sweeping type 90s, you're probably going to be limited to 190 per bend. Okay. But that's what Chapter 9, Table 2 is going to refer to. I actually went and last night I was up a little late looking at some information on that because I sort of remembered it, but I hadn't really thought about it, because nobody actually does that. But it was showing where you just did a normal 90, then you showed this sweeping 90, a concentric type 90. And as you looked at that every 4 inches, by the time you're probably going to be limited to 190 if you're doing it that way. So I would take and say it would be, the question could be true if you were doing some sweeping type 90, but I just don't see people doing that anymore. Plus, to do something like that, it's going to be very time consuming to make that bend. But
we had one job that we did where we were spec'd to do those 90s.
Mm-hmm.
We couldn't get them anywhere. We couldn't get them in a wall. We couldn't get them in a ceiling. We couldn't get them anywhere. We ended up chopping them up and scrapping them because we couldn't use them.
Yeah, that's what I'm saying. You just don't see that anymore. And so then I decided, well, let me go look and check some of the manufacturer specs on the benders themselves. So I looked at Greenlee. I think I looked at another one. I think Milwaukee had a bender, if I'm not mistaken. I looked at one of those, and I looked at Ideal. And I was looking at them, and the only thing I could find on the benders at all was that they had markings on them for 30, 45, 90 degree bend, whatever you were doing, if you're bending saddles and things like that. They had those markings on the bendings, but nowhere did I find anything that said you couldn't bend it more than 90 with that bender.
Yeah, I agree. And it was funny because my apprentice kind of got messed up on this one. He's like, I think my bender goes to 270. I was like, no, your bender doesn't go to 270, bro.
No, but when I looked at it, it's been a long time since I've looked at any of the benders and stuff. And I'm just going off memory. I think the take back on it was 5 inches for bending ½ inch, if I'm not mistaken. That's like 30 years ago. But, I went to go check to see if there's any new additional information I was not aware of, and I couldn't find anything. So I think 90 is perfectly fine. You can bend more than a 90. The only thing that's in the code is from pull point to pull point, no more than 360 degree in the bend, and that's it. So I'm going to say that the myth has been busted.
Yep.
Busted.
Agreed.
All right. Mark, you ready for me to get you set up for topic of the week?
Yes, sir.
All right, let's roll it up.
Okay, I'm going to get started here, and I'm going to share my screen, and let's go. And window, here we go. Share it is. Okay, so let's see, did I share out? There it is. Perfect. Okay, so today we're going to talk about the estimating techniques as it relates to the National Electrical Safety Code. And for the people that don't know me, and most people do know me, I am Mark Candels. I am the president of Candels Electrical Estimating and Training. And I am a licensed electrical contractor in the states of Connecticut, Florida, and North Carolina. And I do sit on the code, National Electrical Safety Code, Panel 4. And I also sit on the UL Standards Technical Panel. That's when we were talking about that fire stopping. So let's go. Buckle up, and this ride's about to begin. Okay, so tonight, this scenario is we've got a renovation project, and it's to an existing building, and the drawing's called to replace 7 rooftop units with new. And we've got to properly size the circuits according to plans. So let's take a look and see what those plans look like here. Here's an existing condition. I actually borrowed this picture from the Electrical Inspector's 2017 program. I was trying to find a picture that would depict what we have here. And presto, I found this baby verbatim.
Nice.
Yeah, it worked out pretty good. So here in the picture, we can see off to the, I'll call it the left, we've got, looks like 2.5-inch conduits coming up through the roof, going into a pull box, and then we're branching off, feeding some disconnects. Off those disconnects, we're going to feed 7 rooftop units with some conduit, and so it's a pretty messy situation here. Go ahead.
One thing I would say is you have grounded materials in your working space if those were likely to be worked on while energized.
You're absolutely right. I would say that's code violation number 1. So it looks like we've got 3 60-amp disconnects. We've got 3 30-amp disconnects, and looks like we've got a 100-amp disconnect feeding these units.
Right.
So let's move on here. I was able to find a like panel schedule, and it looks like rooftop unit number 1 is a 60-amp. I'm going on the right-hand column there. Rooftop unit number 2 is a 60-amp. Rooftop 3 is a 60-amp. So there's a 3 60-amp disconnects. And again, we're talking about existing conditions that are there, and they're basically replacing apples for apples. We're going to go rooftop unit number 4 is a 20-amp, 3-pole. Rooftop 5 is a 25-amp. Rooftop 6 is a 70-amp. And rooftop 7 is a 25-amp. So we're going to keep this in mind. Now, looking at our loads, they're not really giving us much for loads. So nothing's really showing existing. So we're going to have to go to nameplates, right? Is that how you normally do that, James and
Yes,
Willie?
Absolutely, sir.
I will make a comment on them overcurrent devices. You know, as this relates to 2023, so people are aware, you know, there's been some scuttlebutt out there, you know, from certain people. You know, we've had in our publication for over 30 years, when we size a motor, we always start at a minimum. And when you size the minimum, when you go over and look at table 43052, the table says maximum, but that's the maximum percentage for that table. Okay. Then it tells you in 430.52C1 not to exceed the calculated load. So you drop down, and then they took the exception 1 and exception 2, and they're no longer exceptions. They're now 430.52C1A and B, and it tells you in A, without doing any further calculation, you can go up to the next size. And then if you want to go, if it won't start due to inrush current, B allows you to do another calculation, which we call the maximum. Okay. Now, the reason I'm explaining that is because now when you go look at 440.22A in the 2023 NEC, it looks just like 430.52C1. And anybody that's ever looked at the nameplate for an AC unit, you ever notice where it used to say it has the hacker breaker rating, and then it'll say minimum and maximum size?
Yes, sir.
They get that based on the largest compressor load that's on that nameplate, and then you got the condenser, and you take that largest load, and for the minimum, you do it 175%, and then you add whatever the condenser is, and whatever that calculated load is, you drop down the next standard size. Well, now it says in 430 or 440.22A and B, it says without doing any further calculation, I can go up to the next standard size. And then you have the maximum size, which is 225%. So I'm sort of curious on the new nameplates that'll come out if they have a minimum, next, and maximum size for the hacker breaker rating. So that's something we may need to do another one on eventually, showing those calculations, because that is a possibility, especially if we're looking at doing an existing installation like this.
Yeah, James,
Mark, and
have you seen? Hold on a second here. Have you seen the QR codes that they're putting on motors now?
No, I
haven't.
haven't.
You can scan them. You can scan them. It'll give you all the data on it.
Oh, really?
Wow.
That's cool.
Yeah.
I took a continuing ed class last weekend, and they have QR codes out there now that they're putting on motors and transformers. So go ahead, Willie.
Right.
Can I ask
Yeah,
you a question can I ask a question on that, Mark?
Sure.
When you look at that on that QR code, does it give a minimum, next, and maximum size?
I haven't looked at it.
Okay.
It was a slide that I saw. They had them on motors, and they also had them on transformers.
Well, I'd like to see that QR code, because if they set it up like that and it has a minimum, next, and maximum, that defeats the argument that everybody else had against what we've been doing for 30 years.
Right.
Yeah, I agree.
Yeah.
No, basically what my comment is, Mark, is what you have there is basically what you're thinking is the engineered load, and basically what you're gonna bring the customer. And then the reason you need the nameplate is because conditions could change. That mechanical contractor could provide a different unit because it was the only one they could get from Carrier, because
You're right.
that's embargo in Mexico or something,
Mm-hmm.
And so next thing you know, you get a unit that you have sized there for a 60 amp, and it comes out 63 amp. Well, we have to know as electricians, we don't just scrap our whole project and go add a bunch of money to it and go get 80 amp disconnect or 80 amp fuse disconnect. And number 4, our conductors are still going to work fine because our number 6 is good up to 65 amps. But you just have to be able to be good out in the field to know that, hey, it's not necessarily the end of the world when that thing comes out 63 amps. You're still sized correctly on your conductors. You still have the correct conductor size pulled. So that's just important to know.
No, that's great. So what I did was I did a little research here on this project, and we'll just take rooftop unit number 6. The maximum circuit ampacity is 62 amps. So they're calling it maximum overcurrent protection device of 70. That sound right?
Right. Yes, sir.
Okay.
I actually wired one of them.
Good. Rooftop.
I think it's like a 5 ton or 4.5 ton or something like that.
Cool.
That was the nameplate rating.
Yes.
62 amps.
Yep. Seems
no,
high. It seems wrong.
That's not right.
Yeah, it seems wrong.
Yeah, that's wrong.
I have one. I have one I could send you, James. It's exactly that. I think it was minimum circuit ampacity 62 amps or 63 amps, and maximum overcurrent device 80 amps.
Right. But again, I'm taking these off. I took this off the mechanical schedule, and like you said, Willie, once they buy the equipment and once they get the actual equipment on the job, all bets are off. It's going to change. But that's why we need to understand the code. So let's get back to rooftop units 1, 2, and 3. They've got a maximum circuit ampacity of 51 amps with a maximum overcurrent protection device of 60. Again, that seems high. Doesn't seem in line, but maybe they're trying to veer on the side of safety.
It's actually minimum circuit ampacity. I know you said maximum, but
minimum. That's what I meant.
Yeah, you're good.
Yeah. And then our rooftops 4, 5, and 6 have a minimum circuit amp capacity of 22 amps with a maximum overcurrent protection device of 25, which is still a 30 amp disconnect for us. So one of the things I like to do is, hey, where do we go from here? Where do we start? So if I'm going to be designing this, or if I'm going to be looking at it as an estimating side of it, I usually start with, okay, what would the wire size be? So if I was to look at rooftop unit number 6 at 62 amps, so I would probably start off with 310/16, also known as 310/15B 16. And then would you agree that we'd start off with a 75-degree table just for the basis of THHN, and then we talk about D rating where we go to the 90-degree table? Or am I
Yeah, I would go with the 75-degree C just based on the terminals connection. Yep. I would say it would be rare to see a piece of equipment with 60-degree terminals in this day and age.
Yeah,
right.
What I would do here is I'd be looking, first of all, like I was talking about last week, I'd be looking at the terminations, and then I'd be looking, I'm on the rooftop, so I know I'm going to have THW. So in my mind, this is what I'm already thinking. All right.
Most of the conductors we use now, James, are dual rated, so they're THHN/THWN.
That's okay.
Right.
But my whole point behind this is I'm just saying I understand the dual rating, but I'm thinking of the estimating for this. So
okay.
I'm thinking I need a number 6 wire here at 75-degree C terminations. And then I'm thinking, well, there's going to be on top, so I'll have THWN. So since I have that, I know if I go look at table 310.4, I'm going to be using the 75-degree C column through all of this.
Yeah, Mike's on it.
Yep. Right.
Okay.
Absolutely. So, same thing with the rooftops 1, 2, 3. You got 51 amps, and if we went to our 310/15B16, also known as 310/16, depends on what code you're on. The 23, they brought it back to 310/16, correct?
Yes, it's not 15B16 anymore.
That was just a
16.
That was just a 17 hiccup, wasn't it?
It's a hiccup.
Seemed like it.
And I'm being nice about a hiccup. That was just ridiculous.
It was.
So, and then we have our rooftop unit number 4, 5, 6. That's 22 amps. And well, let me ask the question here because I know it's a loaded question. 22 amps. Can we use a number 12, or is it got to be 10?
It's number 12, 25 amps.
Right.
Yeah,
exactly.
I would go number 12. The thing you have to watch out for, like what you're gonna do in this, which probably walking myself into a brick wall, is that when you start getting the ambient correction for being on that rooftop, you have to make sure that raceway is not running on that rooftop for more than 10% of the overall run.
Right. So that's actually coming up in a couple of slides, but great call on that one here. So before we can determine the wire size, we need to do what next? Well, I would say the next thing we got to do is we got to talk about the distance. How far away is it? Right? We got to talk about voltage drop maybe. So right now for the round number sake, we'll just use 100 feet to the panel. So would we have to consider voltage drop at 100 feet?
I'd say no. I wouldn't consider it till over 150.
We did a podcast on this a while back where I went into the American Standards Handbook, and if you're using stranded wire, which you should be these days, I'd say up to 100 foot, you're good. But if you're using solid up there, you may want to look at that because the American Standards Handbook went all the way talking about number 14, number 12, and number 10, and they were actually going up to like 50, 60, 70 foot. at those points that they wanted to see you start looking at applying derating factors. Matter of fact, I'll take and do that next week and go over all that, because that is very interesting to tie it in with what you're doing here in these derating factors, because a lot of it has to deal with the type of conductor you're using also.
Right.
Yeah,
So I'm not going to do all the math, but I wanted this as brain candy here.
Yeah.
Because I wanted to extract this data from the king.
Oh yeah.
Right?
Oh, he's got a thumb rule on that one.
He's got a thumb rule on it. So, hail to the king here.
He basically has a thumb rule on that basically the table, any of the ampacities in the tables, whether there be the 60 degree, 75 degree, 90 degree C, are all based on a 100-foot run.
Right.
Yeah.
Right. So I threw 100-foot out there because I figured that Willie would say, no, we don't need to. We don't need to worry about it. But I knew James would have some insight to it that we just needed to extract here.
When we actually recommend up to 100 foot, it's when you got into solid. And when they first started looking at the amperages for those tables was a long time ago. They actually did those up to 1,000 foot. And that's where we got into a problem, because those conductors were burned up, or else the lights flicker downstream. And based on engineering principles and testing they did, they basically come up with a rule of thumb that was at 100 foot, you should start looking at derating factors for your voltage drop.
Yeah, we actually have a funny thing that we were talking about, Mark. I think you like this. I don't know if James knows about this, but if you go look at, I think it's 90.1, it says basically not necessarily convenient, efficient, practical. There's all this stuff, and so we were sitting there saying, like, if we were going turn on an AC unit and the lights dimmed and we're like, hey, inspector 90.1, you know what I mean? Not necessarily, so basically that's where, voltage drop really isn't required per code to be a consideration. If the lights dim a little bit, then that's just inconvenient.
Some people freak out over that.
Yeah.
Okay, so after we've determined that we don't need or we do need to derate, where do we go next? So let's talk about how many current carrying conductors are in a raceway. Now, we saw the picture. There were 2.5-inch raceways. I think we have a problem right off the bat, but that we'll just throw that out there as that's what's there for existing conditions, and we're probably gonna have to change it. But we really need to look at 310.15B3 A for the adjustment factors for more than 3 current carrying conductors.
Yes, sir.
So go ahead, James.
So, when you get into this with the 2023 code, that's going to be 310.15C1, and then B1 is going to be for your correction factors due to temperature rise and stuff. But when you get in looking at that illustration, I have a feeling that they took and ran up there 2 feeders, and I have a feeling more than likely there might not be more than 3 current carrying conductors in there.
Okay.
I think that's why they ran 2 different ones, is to feed that. Now, if they took and decided they needed more load or whatever, and they did maybe go up there and run maybe a parallel feed up there, now you got to start looking at that. I'm not sure how the setup was there at that junction box, but it could be a parallel feed or it could be 2 individual feeders. Now, if it's parallel, you're going to have to start looking how many conductors did they run in each one and all that, and what they took up there. So if you look at table 310.15C1 and you have, let's just say, 4 current carrying conductors, it's going to tell you got to put an 80% derating factor on that.
Yep.
Yeah,
so
that's kind of a lot of stuff coming out of that J box too.
It is.
That's why I'm saying there's no telling what that's feeding there, because I see a lot of stuff going on there.
You know, you're absolutely right. They could have just run a big feeder over there and just made a big splice or a tap over there. But that's illegal too, isn't it?
Yes, sir.
Mhm.
It could be. There could be some things about the tap rules, but all that would all have to be rated for the 10% of the primary overcurrent device if it was 10 foot, or 1/3 of the primary overcurrent device if it was 20 foot.
I love
Well,
seeing all that flex come out of that pull box feeding these disconnects. Look at what a hack job that is.
Yeah, there's no way that's wet location rated.
I'd be careful calling that a tap because that depends on if it's going out feeding other loads. You see what I'm saying? That
Yeah.
True.
It's sort of hard to tell by looking at it. I don't think it is a tap
Yeah,
per se.
I doubt it.
I
I
don't
doubt it
think
too.
is. Okay. I just
And let's just call it a hack. Let's agree to call it a
Yeah.
hack.
All right. We'll agree to a hack. And maybe we'll have a myth to bust with this one here.
There you go. I like it.
Let me get back to our slide here. So we talked about the distance. We talked about how many current carrying conductors are in there. We really
Right.
don't know. But let's talk about the ambient temperatures up on that roof.
sure.
Now we're coming up through the roof, so we really don't have an issue with that pole box. But do we need to adjust for the load side of those disconnects going out the unit, cutting across the roof? And this is
I would
a question.
actually say there's not enough information to answer that question. If that pull box was, say, like 100 feet away, I would say no.
Right.
If it was like 150 feet away or whatever, I'd say no. But
Right.
if it's like 20 foot to the panel, then yes, that those runs that are exposed to that ambient temperature for more than 10%, and yes, I would say they do need to be corrected.
Well, by looking at the illustration, the feeder is what's coming up there, and I can guarantee you there's not more than 10 foot. So there won't be an adjustment for that feeder per se.
Right.
Now, what you get into is looking at the conductors that are coming from the disconnects over to the AC units. And those there, I would contend, let's say you had an adjustment, say, for 100 degrees, that'd be 91%. I think that's right. Therefore, you could go ahead and put the adjustment, but it's not going to affect the outcome. The conductor's still going to be large enough.
I agree.
Yeah, 100 degrees, 96 to 104, I believe, is 96.
Is it 96?
Correction. 96.
I think I said 91, didn't I?
91 is. Oh, I'm sorry. You are right. 91.
Okay.
You're right. I've got 310. I got 310 15B2A in front of me here, and you're absolutely correct.
Right.
It is 91.
But I'm gonna make an adjustment to that
Yeah.
because now since we're using THWN up there, I'll have to go use the 75-degree C column instead of the 9-degree C.
Okay. So enlighten me, because you just said I was always under the impression that when we talk about correction factors, derating anything, we take the numbers from the 90-degree table. Is that correct?
No, it's not correct.
Okay.
That's only if the conductor is rated at 90 degrees. If that THWN is only rated at 75, correct, James?
Oh,
That's right. Go look at table 310.4, Mark.
310.4. Okay. Let me go up to 310.4.
And pick up THWN, and you'll see in the third column, I think it is, come down and it'll tell you at 75-degree C.
Okay. I'm moving over to my code book right now. 310.4. 310.4.
Yeah, Mike's absolutely right. That's true, Mike.
Yeah, it depends on what conductor you're using. I'm giving variables here that you have to think about.
Sure. Absolutely.
Yeah,
Now,
so
you're saying
Mike's right.
310.4 is a chart?
Yeah, it's a table there.
Okay. I'm not finding that quick in my code book here.
Oh, are you on
Because I go from
2023?
excuse me?
Are you in 2023?
No, I'm on the 17.
Oh, you're in 17.
Oh, that's
Okay,
why.
then go.
Okay.
Go to table 310-104A.
310-104A.
Yeah.
See, that one threw me for a loop, James. That when that changed, because I was used to seeing it in the 17, then it moved like way far away in the 20.
I actually agree with it being up at the front because you need to know the conductor termination limitations. I never thought it should be at the back. I thought because I believe you needed to know that information before you could ever apply the adjustment and correction factors. You see what I'm saying?
That was a weird change. Yeah, that was a weird change.
But it goes back. You just got to know where everything was, and you know I've been doing it so long. I can remember sections back in the
Dude,
90s.
we're gonna find out because I'm gonna get you on the code question of the week. It's coming.
Okay.
I'm gonna get you.
I love it. Yeah, I did find 310-104A, and it clearly says the maximum operating temperatures. It talks about it there.
75.
Let's see. Let me
For
find
THW.
THW is 75 degree. You are absolutely correct.
Okay.
And then they've got special applications for 90 degree within electric discharge lighting. So we're not even going to go down that road.
No. All of that is just for people to think about, depending on the type of conductors you have, the way they're coming up, how you're installing everything. These are all variables that are part of your estimating.
Yep. Absolutely. Absolutely. So let's see. Let's go on to, we talked about the ambient temperature correction.
Yep.
We're not going to do all this math. So, I'm not going to go through what's our wire size and all that fun stuff because, we'd be here for hours trying to size them. I'm thinking about we'd have to go and size all the conductors.
Right.
And then we'd have to go to table C1 to fill out the tables that are over there.
I would go with the number 6 for the one. I would go with I can't remember number 6
let me go back.
for the
Let me go back here. So
I would say you would have to go with number 6 for RTU number 6. I think that you're just over on RTU number 1, 2, 3. I think you'd have to go with number 6 there as well.
Yeah, I would agree with you.
And then I would just go with number 12 for 4, 5, and 6. As long as it's not too much over 100 foot.
So
it started going.
What about if we're going to cram them into a couple conduits?
Well, now see, all those ones that you showed in that picture were all individual. So
yeah,
you're only looking at.
Let's go back to the picture. The feed coming into them were crammed into 2-inch conduits.
Yeah, good point. But they're all individually ran. And like I say,
the loads coming out are individual ran, but I hate to use the word feeders because we talked about that last week. The circuits going up to that pull box.
I don't see no fuse disconnect in there.
Well, now if they were running all those up to that junction box, all those conductors coming up to that junction box and then branching out to each one of them, that's all branch circuit all the way from the panel board.
Right.
Now,
we'd have to do an adjustment for more than 3 current carrying conductors.
That's right. Now you're probably looking at an adjustment.
I would say about 70%.
You'll be right at 70%. Yeah, I'd say 70%.
So that's
welcome in Joseph Dumpy. Joseph Dumpy from New Jersey's in the house.
Hey, Joseph.
Welcome aboard, Joseph.
All right, let's move forward.
All right, let's move forward.
I'm enjoying this.
Yeah. So actually, there is I just lost it here. That was really the gist of my PowerPoint here.
Okay. Oh, you did great, Mark. That was good.
Can I expand on that?
Absolutely.
Now let's look if we're sizing the overcurrent device. There was sizes that were given there. Okay.
Right.
Now, if you go look at 440.22a, it tells you that you're going to take the nameplate value and it's going to tell you to take it at 175%. Okay. And that is for the minimum.
Right.
So if I took the 65 amps at 175%, that's going to give you 113.75 amps. Okay. So the
Right.
next size below that, if I go look at table 240.6A, is going to be 110 amp overcurrent device. You see that?
Yeah, I do.
That's why I wasn't on board with the 80 right away.
Right.
Now, if it won't start due to inrush current, and it tells me I can go up to a maximum, I can take that at 225%. That's going to give you 146.25 amps. The next size below that's going to be a 125 amp. So you could have anywhere from a 110 amp to 125 amp on there.
You could.
And that's why I'm saying if you go and you do the nameplate calculation and then you look on there, there's a reason they have the minimum and maximum size overcurrent device. It's sized based on that nameplate and those percentages that are in table 440.22A. So that's why I was curious, why did the nameplate say 80 amps on it? Is it something, maybe it's due to something, maybe because it's more energy efficient or something? Is that the reason?
Well, so what you have to understand, James, is that nameplate that we had in my case, so it's 63 amps, right?
Mm-hmm.
So you have to deduct 125% because that minimum circuit ampacity is 125% added. So you have to deduct that 125%, and then that's what brings you up to the 80 amps.
Okay, that's where I was misunderstanding. So they already put the 125% on there for the conductor sizing.
Yes, sir.
Okay, got it.
Yep.
Then we're good. All right.
I still want to see this QR code thing.
I do.
Oh,
too.
yeah.
It's the minute I
That's
find it, I'll be texting you guys here.
Yeah, I'd like to see that because I'd like to see, especially on motors, how they go about classifying it. Because when you look at the nameplate for an AC unit, it specifically says minimum and maximum. I mean, there's a reason when we do our motor calculations, we've always said minimum, next size, and maximum, is because that is an established principle that people use to understand how to do the calculations. Been doing it for over 30 years. You know?
Yeah, and Joseph Dumpy, greetings all. I usually see this question for temp rather than amps, and good exercise. You know, thanks for joining, Joseph. Great comment, sir.
Thanks, Joseph. It's good.
I love it.
I do too. I think this is great. We got to do this more often.
I remember when I went on Mark's podcast right before we were going to start, he goes, all right. He goes, how do you want to do this? I said, just whatever you want to talk about, Mark. I said, just give me a lead in and I'll take over from there. He goes, I can't believe you just did all that on top of your head.
That's it. I threw the fishing line out there with the bait on, and he just took it and he just ran like Jaws.
Yeah, me and Mark had a lot of fun. I did a podcast with Mark, and it was a lot of fun. Just talking about war stories. They actually call me war stories at work because I have so many war stories. But it's just, you know, you learn from experience. You know,
we do. We
ran into a thing where I'm trying to get a signal through a conductor, not realizing that for every 1,000 foot, you have a 4 ohms resistance. And this company that we're doing this for, this engineering company, they have a resistance max at 54 ohms. Why do they have a resistance max at 54 ohms? Because you can't get a signal through 54 ohms.
You mentioned that last week where you were trying to tone out a cable.
Yeah. Couldn't even get tone through it.
Because of the distance.
Right. You know, and that goes to show you a lot of times, especially guys that have been in the trade a long time, you always want to listen to our guy because they have so much experience in things they've run into. You know, it one it reminds me of. Even Bill and I were like, I never heard that. But we had Dad on the podcast, and he was doing grounding, and he literally told us how they developed table 250.66 and the multiplier they used to do it. And I thought I really knew about everything. And I was sitting there, I said, oh, wait a minute. I said, you tell me they took that on device and took that multiplier? He goes, yeah. He goes, add it up. And we had a guy come on that tried to say it wasn't right on NEC for Dummies. And he did the calculation all wrong. And I showed him how to do it exactly how Dad said. And how many did I do? Like 3 of them, Bill, or something? They were exactly how he said they did it. And I was like, that is unbelievable. That kind of knowledge, somebody that was there at the time and what the panel's intention was and the task group that developed that table and how they did it. That of all the things I heard in the code before, that amazed me more than anything, that it was a multiplier that developed that table.
Wow.
So you know how they did it, Mark, which was really impressive to me too.
What's that?
They almost kind of reversed it back. So what they did was they went to table 250-102, or was it 250-102C, and they basically took the overcurrent device, what size you would use, and then they reverse engineered that into a multiplier, and then they took that conductor size and then made that for your service entrance.
Yeah,
will that work here?
Yeah, it'll
My
work.
code calculator?
That.
Yeah,
It'll work. Hey, they did
I love
that
this thing.
at that time. Bill, that was table 250.9 or 250-96B that they reverse engineered off of. That's right.
Yeah. And it was just so amazing. Like both me and James are just like sponges sitting there learning all this stuff. We're like, whoa, this is cool. And then we were like all clouding everyone, like, you guys don't even know what a made electrode is, because they actually removed made electrodes from the code. But that's what basically a made electrodes are moved to 250 66 A through C, and then all other electrodes were sized off the table.
That's right.
Yeah.
And what's interesting, and people still argue this, they say, oh, if you're going to a concrete encased electrode, you can go smaller than number 4. And I told them, no, you can't do that. And I actually went back and got the information from the code making panel, and the language that they're talking about hasn't even changed till today. And they even stated a number 6 was considered too small.
Wow.
I mean, it is amazing when you go back and look at all the testing and what the intent was by the code making panel at that time, and what their desired intent was at the end of the day, and what they wanted you to do as far as it concerned the grounding of grounding electroconductors and grounding electrodes. It was really amazing listening to him teach all of that.
Dude, I learned so much that day. And the thing was too, that they actually showed the public inputs that people were saying, can we use a smaller size sole conductor to that electrode? So that's the first time where you actually were able to combine electrodes. So you can run like a number 8 from your service. Like if it's small enough, you could run number 8. You could hit a grounding plate. Then you could run number 4 from this. You could run number 6 from this, and you could combine them all. And then you could just run one conductor from there to your service. You know what I mean?
But
and
it'll have to be based on the largest one you're looping in, though.
Yeah,
right.
The largest conductor.
Yeah,
size off the table. But
I'll say this: when Dad did that, I'm not the king; he's the king.
Yeah. That was good, man. That was good. Didn't you say the multiplier is 187.187?
187 is what he said. I'd never heard anything like that. I was like, wow. And I said, we need to put that in our publication, because I didn't know that.
Yeah, that was good engineering. Are we ready to do the tool review?
Yeah.
Yes.
Let me cue you up, brother.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. Well, everyone knows that I'm a DeWalt guy, and I really like DeWalt. I flip it back and forth just to make it fair, so all the Milwaukee fans out there that are members of our tool group can get represented. But this week, Mark Candell has told me about this gyroscopic screwdriver. I'm gonna have to go buy one. I haven't actually used one yet, but I'm sure the battery lasts 10 times longer than the Milwaukee version. But altogether, it looks like a pretty good tool. And Mark's telling me that if you twist it right, it turns right. If you twist it left, it turns left.
Absolutely.
So that's pretty cool.
You want to turn my camera back on? I've got one here in my hand. Or you can't do that.
Let me see. We could do this.
There we go. So
yeah,
this is the gyro. I love this thing. I stumbled across it at one of the home improvement stores one day, and I did have the Milwaukee, but like you said, the batteries didn't last long. These little babies last a while, and
Nice.
It's got a little pistol grip on it. But what I like about it is you just turn it right and it starts going. You turn it left, it starts going.
Wow.
So forward, reverse. This thing is the cat's meow. It's got a little holster up here for your bits.
Wow.
I keep this all over. I mean, it's great. You can take panel covers off. You can do devices real quick. It's got a little flashlight on it. It's pretty cool. My guys love these things.
And
So you're saying those things are about $99, aren't they?
Yeah, they're about $100. They'll come with 2 batteries and a case. And if you buy the kit, it has a little tool holder on top, the bit holder. But it's nice. It's got adjustable clutch on it. And I had to paint it because it keeps walking out of my toolbox.
you know what you need to ask Bill?
What's that?
Does it have a good battery life?
Oh man, I think I walked into that one.
You did. But I've got a split shop here in our lovely company here, and I'd like to give a big shout out to all of our peeps here in Babcock Ranch, Florida. It's the first self-sustainable community of its kind in the United States.
Awesome.
We're completely solar, so we've got quite a crew out here. We got a mixed bag of the Milwaukee guys and the DeWalt guys. So we do a lot of jabbing at each other, but both companies make some great stuff.
Yeah, they do.
I agree.
They really do. I've got both in my truck. So
Awesome.
Well, I have an interesting Milwaukee story. So this is where it all got really funny. My apprentice had something mess up with he had a brand new Milwaukee drill. Something messed up with it. And he's going to, warranty it and everything. And he calls up the warranty company and he's putting it on speaker so I could hear how great their warranty is, And I'm like, oh, okay, cool. I want to listen to this, I was like, all right. And the lady says, well, did you put your name on it? And he says, what? She goes, well, yeah, if you put your name on it or something, then we know it's been on a job site. And I was like, what? I'm like sitting there listening, like, what? And then he goes, no, I didn't put my name on it yet or whatever. She goes, oh man, because we design all our tools only for home use. Oh man, I was sitting there. Just rolling. That was the funniest thing. And he's just, ma'am, can you hear me? I'm just sitting there laughing, and it was so funny. He took it off speaker. He's like, yeah, can you warranty it? Whatever. And he ended up getting it warranty, but ever since then, I'm like, hey, get that homeowner crap out of here.
So one thing what we do is we'll keep an extra set of tools, power tools, drills, everything, at the shop. So like if the apprentice forgets his tools one day and he needs a drill or whatever, we have a set that are painted pink.
Oh, there you go. Do you got the pink hard hat too in case he forgets?
Yeah, we have a pink hard hat too.
There
you forgot
you
your
go.
PPE. You're gonna wear the pink one. They'll never forget it again.
Love the pink hard hat.
Yep.
So I don't know if you noticed, Mark, on the last few shows, I always slip a little slide in for James, try to kind of pull him a little bit.
I've been waiting for it. I've been waiting for it. I've got my seatbelt on.
wrong, or I might get him. I don't know. You never know. But
All right. Well, I'd like to see it.
Good question of the week.
All right, here we go.
Because James was on it last week.
Let's see. If this is not a motor circuit and part of a branch circuit, it's fine. D, 80 amps.
Dang, nailed it.
That's an easy
Nailed
one.
it.
You didn't even give me a hard one this week. That was easy.
Hey, I knew you would get that one, but I wanted to give our winners a big shout out and pop them up on the banner.
I forgot to do that.
Oh, all right. Well,
we'll put them up at the first of next week. I forgot. I had so much going on.
It's all good. But
I was getting emails from James at 4 this morning.
So congratulations, all the winners of the Code Question of the Week. Yeah, I put winners on there, and I'll put winners on your thing, so you're the winner. But we do like to give you a shout out. And Jackson Roos was first place this week, and he nailed it too. But it's really awesome to have so many code people that are just really sharp on the code. And I'm going to try to get some little bit more complicated ones, but I'm trying to get ones that are just fun for the apprentices where they're able to answer them. And that the whole thing that's funny is there is no options that are correct, because obviously you're not going to post a question where there's no right answer.
I bet you if you had asked an apprentice what an outlet is, they'd tell you.
Ooh, that's the thing that's funny about that is that code making panel members have been, quoted saying that if you remove the receptacle, do you remove the hazard? Well, for years and years and years and years and years, when you hardwire it, you're that's what you're doing. That's the reason you're hardwiring it. You're removing that hazard to personnel. So I kind of don't agree with them saying that you're not removing the hazard by removing the receptacle. So to me, I think this is kind of muddy in the waters. And James knows about this one when they said that hardwired AC unit is considered other outlets. It needs to be 10 foot from a pole. Now they're starting to kind of get into this quicksand that is a little rough, and they're showing pictures where it's like a rooftop pool and there's AC units within 3 foot of the pool. And I don't see that being a code violation, but it's going to be rough because you're going to actually have to build a condensing unit stand on your high rise so that all your condensing units can be 10 foot from a pool. And I don't know that that's going to really be happening. And it's hard to deal with some of their interpretations on this ACs or outlets thing.
It's like I said when you asked me that, I said, well, explain this to me. If everything's an outlet, why do you have to have other outlets?
Yeah. Exactly.
And Bill goes, that's a good question.
Yeah.
I said, yeah.
Yeah, exactly.
Because there is a section on other outlets.
That's right.
Well, and then you run into, let's just say it's a 480 volt cord and plug connected pressure washer. Well,
right.
Now you have to have the special purpose GFCI, which is a trip at 20 million.
Right.
Yeah. But I still don't think it has a 10-foot limit on that.
No, it doesn't. And that's what I was saying. There's a reason you have these special GFCIs at different milliamps, because they're for the equipment. It doesn't have anything to do with protecting personnel. And it does protect personnel because it's protecting the equipment before it happens. But, there's a reason that you have those SP GFCIs for that reason. And if everything is just an outlet, there's no need for those special GFCIs. I mean, it makes no sense to me.
And there's not a need for the definition of individual branch circuit, because every branch circuit terminates to an outlet regardless.
That's a bunch of crap. I brought that up when it first happened. And I said, there's a reason it goes to a single piece of equipment, and it says utilization equipment. It doesn't say outlets or utilization equipment. There's a reason it says that. And then they come back and they said, well, you need to look at the definition of a branch circuit. I said, well, if everything's an outlet, why do you need an individual one then? It makes no sense,
Right.
because if you actually look at the definition of branch circuit, it says outlet or outlets. You ever notice that? And so
Yeah.
it could be one or multiple outlets. When you go to an individual, it specifically states it goes to where? Utilization equipment. It doesn't say anything about an outlet.
No.
But that's my
Yeah.
opinion on it.
Yeah.
Yeah, I mean, it's gonna be a tricky one, I think, moving forward, just because we've asked numerous people, like, where is it? Because my basic issue with it is, okay, so the Class A protection is for the personnel. So the personnel need to be protected from that point. That's the point the personnel need to be protected from. You're not protecting the equipment. So if you sit there and say the protection is at those terminals at the unit, then you're not protecting the personnel, you're protecting the equipment. And then when you sit there and say, no, it's the load side of the disconnect, well, no, it can't be a device and an outlet at the same time. You can't put both definitions at one place. And then they're like, oh, it's actually the seal type that goes into the unit. No, it's not. And the whole thing is that is not likely to become energized. So
they'll probably come out with a new category, the .2 of definitions of each chapter. They'll have like a .2A or something like that. More definitions, trying to elaborate on it.
It's like Bill told me that. They said it was at the end of the wiring minute. I said, so basically it's a Lucky Charms. It just is an infinite point, and it just magically exists.
That's right.
Exactly. Yeah. But that's the whole point of the Class A protection. Like that's been my argument since day one. Like, what is the Class A for? Like, but you have these window shakers in hotel rooms that are GFPE, and that's totally fine.
Yeah, if you remember, I brought that up to him.
Yeah.
The first time it all happened, Mark, it was basically, I went on Bill's podcast, Willie Jackerson. He's asking about GFCI protection, and he hit me. He goes, that's an outlet. I said, no, it isn't. I said, who told you that? And I started going over. He said, well, they say it's at the disconnecting means. I said, no, it isn't. And so the next thing I know, I started getting attacked for it.
Oh, no.
And they told me it was at the disconnecting means. And I said, well, the disconnecting means is a device. And I said, you go look at a device. And they took like 2 hours. Then they come back and told me it's at the AC equipment. And I said,
oh yeah.
I said, is that rated for a wet location? They said, what the hell's that got to do? I said, well, if I put any outlet that's out there outside, just like a box or something, I said, it has to be rated for a wet location. And they said, well, that's inside the equipment. The manufacturer has that. I said, that's right. I said, so how can you apply an NEC requirement inside listed equipment by UL?
Right.
And boy, they got off of that. Then the next thing I know, they come back and said it's the wiring method. I mean, they just kept going from point. And then at the end of it all, they come back and said, we've always maintained it was at the end of the wiring method. I said, you're lying.
Dude, I think Willie actually took one for the team on that one, because they called his podcast the Hee Haw podcast. You know what I mean? And they didn't want to listen to the Hee Haw podcast, but that was one of the most listened to episodes ever. So I didn't really I didn't really see what Willie's angle was at first, but he did good. He got her done.
It was funny because we did that at the last minute. He called me and we did it the next day. And it was just like a quick. He goes, what do you want to cover? I said, whatever you want. I don't care. And so then we show up, and he goes, we're doing GFCI protection. And I was thinking we were just going to do, look at 210.8A and B, and I would explain all the GFCL requirements. Oh no, it was about the outlet.
Well, and see, the thing was too, Mark, I was working at an industrial plant, and I'm sitting there seeing all this hardwired equipment everywhere. And I'm sitting there like, that's an outlet, that's an outlet, that's an outlet,
boy.
that's an outlet.
You made a lot of friends that day.
And well, I'm just saying in my head, that's what I'm thinking, because I'm going around this industrial plant. And one thing we have is we have this thing where we have to gown up and we have to like wash our hands and everything before we go into the production facility.
Right.
And when we're doing that, they got these plastic hand dryers,
Mm-hmm.
and they're like, you go put your hands in there and you dry your hands and everything before you go in the facility. And I'm thinking they're calling that an outlet. You know what I mean? And so I'm sitting there thinking to myself, I'm like, okay. And I'm looking at the circuit labeling on them, and they're 208 volts, single phase, and so I'm like, got all these 208 volt single phase circuits on every single one. So every single one was 208 volt.
Right.
And I'm sitting there thinking like, okay, they're saying that's an outlet. You know what I mean?
Yeah.
And so I'm going home. We're gonna do this podcast. It's gonna be on freaking because I was like, there's no way. This is garbage, man. I'm done.
Yeah,
and I did. It took me about an hour to get it all set up, but James did a good job jumping on, and
he always does.
Hammered it. Yeah, we
well,
jumped on.
thank
We
you. I
hammered
appreciate it, guys.
That
It's
was
like
good.
I tell everybody after 35 years of being all over the country, and I used to. They don't do it anymore, but I used to teach, NFPA's programs for them for 30 plus years, and using other people's material. And plus, Dad and we updated the safety manual for the Department of Energy and Defense. We wrote the inspection procedure for all the pump stations up in Alaska and all around the United States for Exxon and all of them. I'll tell you, you learn a lot of crap real fast when you have to start researching all that stuff.
Oh, yeah.
and tying it in not only with National Electrical Code, but you got to look at OSHA regulations. You got to look at other standards, because there's other things that they do that will have a direct relationship in that area with other NFPA standards. So we had to look all that stuff up. And, after doing that, if you didn't learn something, then you wasn't working. That's all I'm going to say. You got to put time. It's just like you writing your software. Tell me, don't you learn something new every day? Every day you're going to learn something new.
Sure. Every day.
Dude, and that's the thing, what I've learned too, with like the fire alarm. There's so many different things that I've learned. I know me and James did like
the technology
show.
changes every day.
Yeah, we did a show on like DC. I think it was like DC theory. And I had like a whole bunch of valid insights on Class A, Class B circuits and stuff like that, just because I could see them in my head. We were sitting there one night and I was like, dude, I want to make this freaking motor thing. And James starts just plugging in, terminals and colors. And I'm like, no, that's wrong color. No, I can't use that. I was like, and I had the exact colors of a wedge motor, all the way through, and it was just from my head because I wired so many of them,
That was the one we did right here.
Yeah,
that's it.
Yeah, we did. Believe it or not, we did all of that in like 20 minutes. I built that whole thing and put it in as a logo.
Wow.
Yeah, I was like, and it's funny because like if you look at the line leads, that's actually your motor rotation right there. Mm-hmm. So I think it has what, blue, white, orange, or I can't remember what your line leads are.
Yeah, blue, white, and orange.
Yeah, so that's actually a rotation. So if you reverse any of those, like usually what I do is I put yellow to white if you're on a reverse rotation, like when you're going like 480. Mm-hmm. So I'll put brown to blue, orange to orange, and then yellow to white, and that'll get it to turn right.
Mm-hmm. It is interesting just being able to do things that quick. And that's one of the things I'm real excited about, because the new illustrations that are about to come out in the online course for the generator, transformer, motor, compressor book, and our troubleshooting chapter, I think it's chapter 21, if I'm not mistaken. We actually go through all the motors and the rotations and stuff. We even take a motor showing you where it has no markings at all and how to ohm it out and how to mark those wires based on how you ohm it out in order to figure out how that motor is supposed to be wired correctly.
That's amazing.
Dude, well, funny thing too, Mark.
Yep.
James was on NEC Live, and he did a great job. He was on 2 weeks in a row, and he had like one of the most viewers ever on NEC Live. And it was funny because one of the guys says, "What's a motor?" That still cracks me up, man.
Well, I tell you, sometimes you get to talking fast.
I just thought it was funny because I was like, yeah, I'm going to give James a crap about that for a long time.
Oh, Derek and all them were. Derek was funny. Derek goes, because he was wanting to show the NFPA link, and he goes, James, slow down. We can't keep up with you. I was like, okay. But I think in that episode, I bet you I probably answered probably 10, 20 questions each show. There was people asking me all kinds of stuff. Like one of them, he was asking about a tap rule and how to size it. And I said, well, I'll give you a rule of thumb. It's very simple. If it's 10 foot or less, divide by 10. Everything else you take at a third. And if you have a transformer in there, you got to get the ratio of the transformer for the secondary side, but you still take the primary to third and the secondary third. I said, you can read all that information you want, but that's how you do it. Yeah. And one of the guys or Derek was there. Derek goes, I don't think I've ever heard it explained like that. I said, that's how you do it. And I did a few tap rules real quick, and Derek goes, what you're saying is correct. I said, yeah. I said, that's the years of experience in teaching. You learn that stuff. And I've always, when I've tried to do any type of instructional work, I've always tried to make it as simple as possible. How is it the simplest way for somebody to understand it so they'll know how to apply those rules when they're out in the field, that they don't have to, it's something easy they can remember.
Mm-hmm.
Yeah, I agree with that. And that's kind of how I teach, like I teach my apprentices like through experience, and I just say, like, what are you getting ready to do? Well, I'm getting ready to go do this. Well, what do you need? Well, first I need I need a drill from DeWalt, whatever. Okay, well that's fine, but you have to have that knowledge of where to go, what screws to turn. You know what I mean? Like, you don't just like a lot of guys. I just need a tool. Well, yeah, that's fine, but you have to have that knowledge of where to use that tool, how to use that tool. And I try to teach them like, hey, what's your next step? Okay, you got your tool. All right, now what you need to know? Well, I guess what I'm working on.
That's
and
right.
I feel that that's how we're making ourselves safer as electricians and working on the jobs, is we're able to identify like, hey, we need to have our tools, we need to have our stuff, we need to have our material, we need to like look ahead, we need to make sure we're being productive every day. And when we're doing that, it's making us better as electricians, it's making us better as leaders. We're able to lead by example. I put my tools on almost every day, and I never get nothing done, but at least I put my tools on and I walk around and I act like I'm getting stuff done.
Good.
But yeah, the whole thing is, it's like when you're in that hospital environment, I mean, it is a freaking ocean. I mean, there's just so many things going on. It's like they're sitting there calling me, yeah, we got a ground fault in this circuit over here. And I'm like, yeah, it's going to be like 20 minutes. Then they call me back, it's cleared. It's like, didn't even have time to walk over there.
Yeah, gotta walk all the way.
I know exactly what's going on. Somebody's messing around. Oh, he's messing around on the fire alarm system.
Yeah.
Don't be screwing around. You're screwing around on the fire alarm system.
Oh boy. So James, I uncovered another 2005 Stall Cup book.
Did you
Nice.
get the new 2023 yet?
I haven't yet.
I know you called me the other, or
I
sent me a
did.
message to
I
get it.
did. I haven't had time. I've been working night and day here, but I'm gonna get the 23 going here.
I know.
Yep.
I keep hearing that I'm getting a 2023 code change edition, but
It's coming.
at least the PDF.
I'll tell you the new setup. It's coming with online. I'm telling you, it's going to blow everybody. It is unbelievable the things I've got going right now.
Great.
And
can't wait to see it.
It's going to be top notch. Yeah, I'll tell you what's the most impressive thing to me. Not only is there tons of information, you have access to your fingertips, all that. That's great. Great. The new illustrations are fantastic. I love them, everything. But the thing that impresses me the most is how simple it is to use it. It's just click, boom, click,
Nice.
boom. And it's all right there, videos, illustrations. That I've never seen any training like this. And I was showing, I can't say who I was showing because we're actually maybe working a deal, but I was showing them how to do the calculations online. And I said, let me make up a problem that has nothing to do with this. And I just put in the values right there, showed him how to do it. He goes, so you can do anything with this? I said, yeah. And I said, this gives you a step-by-step layout of how you're supposed to do it. And then you actually have a form that's there that you could put your own values in if you're out on the job and fill in the size, your conductors, your overcurrent devices, whatever it is you want to do. And plus you can click and go get the table and see the percentages and everything. It's all right there for you.
Nice. Can't wait to see it.
Yep.
Hey, so when are we gonna get State of Colorado?
We're getting there. I'm telling you, we're getting there.
All right.
I'm hoping to submit it within the month.
Okay.
So we're
Sweet.
getting really close. It's just a lot of work getting it all done, but we're getting.
I'm just trying to push because I'm not gonna take it till September, right?
I know. I don't think we're gonna have a problem with Colorado, Texas, and a few others because I've already contacted them. They already know about it and everything, and they had seen previous examples of it and stuff. And I actually had, I'm not going to say who they were, but I've had 3 states that have told me that's the most impressive training they've seen.
That's
that
nice.
come through. So,
Nice.
and I know here in the state of Texas, Jerry Daniels already made the comment that a lot of the online education that's being put out right now, they're not happy with it because it's just a picture and some text. He said, hell, I can do that on my own.
Yeah.
And there's no like real training, and ours, we actually had the video and I write all the scripts with voiceover. And it's just like we're in class. We tell you what happened, what they did. And I'll tell you another interesting thing that's in it. You can actually go in and click, and I have it in the video. And then also with the illustration, I have a tab that's up there. You can click and see the code making panel, their first revision and second revision. If they're both there, it could be just one, but you can click that and see their substantiation and how they voted on that and what their interpretation was. I've never seen that in another program.
Right.
Yeah,
Nice.
and I really enjoyed some of this stuff. I don't know if you know this, Mark, but I actually got James on the what was it, 110.12 code change for 2023 on the professional and skillful manner. That was actually a code change from neat and workmanlike manner.
Oh, yeah, he was asking me that. I forgot about that. That wasn't even on the question of the week. That was something he asked me, and I said, I don't remember that change. I went back and looked. I was like, some bitch.
Because is it
Gotcha.
110.12 is the shall be in a neat and workmanlike manner. Is that correct?
Right.
Yes,
Right.
sir. And in 2023, it changed to must be installed in a professional and skillful manner. That was actually the code change for 2023. And
Really?
I gotcha, James.
That's okay.
I know. But the whole thing was that there's certain ones that I think highly of. And I think that is actually one code that's been in there since the first code book ever and never been changed. I think that was the first time it's ever changed since 1800s.
Almost like the definition of an outlet.
Oh,
Shots fired. Oh my goodness. I mean, when I was going to trade school back in the late 70s, early 80s, they used to beat in our head 110.12. Electrical equipment shall be installed in a neat and workmanlike manner. It's just embedded in my head,
Yeah, me too. That's the way I've always thought of it.
And keep in mind, I just got my NISAT 2. I got my NISAT 1 and NISAT 2. And they actually say in there that they have a neat and workmanlike manner that is enforceable in NFPA 72. So it's not really enforceable, in my opinion, in NFPA 70. But I would actually say it is enforceable in NFPA 72. Because if it's not installed in a neat and workmanlike manner in NFPA 72, then you're not a qualified individual. So you have to be qualified to perform fire alarm work, and if you're not performing it in a neat and workmanlike manner, then you're not qualified. Shouldn't even be there.
I believe everything should be done in a neat and workmanlike manner.
Yeah, I don't care NFPA 72 or 70.
Yeah,
should be in the neat and workmanlike manner.
I always tell my apprentice, yeah, well, you got the engineers getting ready to come look at it. Are you proud of it? Better be proud of it. You better be proud of everything. And then they get up there and the label's all crooked, and I'm just like, really? I was like,
well, I'm sitting here looking. I think Bill needs to get off. He needs to go watch his favorite team playing.
Yeah, he does.
In the playoffs.
Oh, the Stars?
Yeah, they're tied 2-2 with the Wild right now. I'm actually gonna go up.
Oh, you're talking about the Kraken?
And hang out with the guys tonight. Watch it.
Nice. Yeah, James. I am actually gonna pull for the Stars.
I know you are. I'd pull for Colorado too.
I typically wouldn't pull for the Stars, with all our history going back. But no, it's good to see the playoffs, and I want to go up to the safety meeting and be like, release the Kraken. You know what I mean? Like, just like after they beat them. But I don't know. It's a tight series. It's gonna be close, and
it is.
I would like to see Stars win, but we'll see how it goes.
Well, one of my friends, believe it or not, his name's Bill too, but Bill Joel, and he is a big Stars fan. He's got season tickets and everything. Matter of fact, I think he's at the game tonight because they're playing here. Because he's not going up there, so I'm sure that's where he's at. But he is full like you. He's fully invested in the Stars. And I was teasing him before. I told him, I go, well, hell, they ain't gonna beat Colorado. And then Colorado loses. He goes, see, Colorado ain't any good. I told you that. And it just back and forth.
You gotta bring the Hansons out.
I actually thought Colorado would probably win it again. I did not think the Wild would beat them, and then when they did, I was like,
"Yeah, it was actually the Kraken. The Kraken beat Colorado.
Yeah, Kraken.
It's their second year. That was their first ever playoff game. Their first ever playoff series. We just wanted them to feel special, but
you did.
The whole thing is we lost a lot of players due to injury this season, and it just kind of felt like the train just kind of came off the rails at the last minute. We lost Nuke. That was hard, losing Nuke. I mean, he just scored a goal in the game before that to give us a win. Then he ends up having to go through this whole thing with this gal. Some gal got alcohol poisoning, some gal from Russia or something, and he had to get back and deal with that whole thing or whatever happened. And so it was just rough. And, it's hard to say. I mean, Landeskog actually had another surgery, so he's going to be out for the whole next season. So we're not getting Landy back anytime soon. So it's pretty rough. It's rough for the Avs, but who knows? I mean, it's any given season, any given playoff, anything could happen. And I would love to say that if the Stars lose, I'm going to say release the Kraken.
Okay, I'll take it.
Yep.
I watched one of the games the other night. We were at the pool hall. I don't know how them guys see that damn puck. Man, that thing's moving so damn fast. I don't see how they see it. I'm like, their hand comes up to the I'm like, how the hell did you see that? Yeah. I mean, hell, it amazed me. Those guys are talented, man. I'm like, wow.
Well, look at Joe Pavelski on the Stars. He did like 3 in a row one night.
Yeah.
The same thing what you're talking about. He just raised his stick up and just touched it and knocked it down in.
It amazed me those guys do that. God dang.
I'm catching a game tomorrow with Linda. We're watching our local team, the Florida Everblades here, which is the farm team for the Carolina Hurricanes.
Oh, okay.
So they're they're doing really well. They won the Eastern Cup last year, so they're doing well again.
I remember
the games we go to up here, Mark, they're actually the Colorado Eagles. And they're actually kind of the farm team for the Avs, but they're like the Northern Colorado, like minor league. But those games are so much fun, and they're actually in the playoffs right now. They're in
nice.
They actually went to the next round of the playoffs. So
yeah, I remember we went to one we had here. It was called the Fort Worth Brahms in Fort Worth, and I took my son to see it. I think he was like 5 or 6 at the time. I mean. We had got him hot dogs, all this stuff. We sat down. It wasn't like 2 minutes. And all of a sudden, all the gloves were off. They were out there hitting.
I love it.
And my son, he's 5 years old. He goes, they're fighting. And everybody's like, yeah, kick his ass.
That's why we came here.
And he was
not
just
a good game without a fight.
He come over and told Mom they were fighting, Mama. He goes, all of them were out there fighting. And she goes, well, they really wasn't fighting, son. That is part of hockey. He just couldn't get that.
Yeah, I went to a hockey game and a fight broke out.
Yeah. Right. I just didn't expect it to happen that quick and the whole dang bench clears.
Yeah.
Oh, great time.
Yeah, there's a lot of bad blood out there, but really awesome. Thanks for joining us, Mark.
Thank you.
It was a great time having you, man.
Awesome.
You put on a great presentation, and anybody wants to ask any questions of any of us, feel free to jump on Nat King Code, Mark Candel's Estimating, Volt Online Academy. We're always open to answer your questions and whatever you want. The secrets of the world and bring us myths. We'll take on myths all you want. I know Mark has brought me some myths in times before where he's like, yeah, what about this? And so we'll roll them.
Yeah,
that's what it's a lot of fun. Yeah, I appreciate it. James gets the most amount of myths because his publications go back, so long, and now all of a sudden they become wrong in 2023. So we gotta back them up and prove that we have to bust some myths on you, brother.
I'll tell you a quick story. We were at an IEC meeting, and I forget this lady's name. It's been a long time ago, and we used to go. It was for the instructors. It wasn't just the IEC meeting, and we would have a room and people would come in there if they had any questions about your publications and all this. Well, they were actually pushing to use something else. And if you ask me, somebody was getting some money.
Yeah.
But she come in there and told me our publications were wrong, blah, 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 blah. And I said, won't you tell me where we're wrong at? And she goes, why?
Well, no, wasn't it? You were saying that they said there's a bunch of mistakes in it.
Yeah.
And then you're like, okay, where's the mistakes at?
Yeah. And she goes, well, I don't remember. I said, now, wait a minute. I said, I'm specifically here to answer questions of anything you think's wrong. I said, but yet you can't show me where it is. I said, maybe what's the problem is here, you don't want to show me where these mistakes are because I'm going to show you where you're wrong and you don't understand that section.
Yeah.
And she goes, I don't appreciate you talking to me that way. And I said, I don't appreciate you coming here making assumptions on something that you can't back up. I said, you can't come in to my room and say something like that with no proof. And I said, I'm the one that should be offended here, not you. And so then they had this big thing, and and NFPA was actually our publisher at the time when all this happened. And you know what's interesting? People don't realize NFPA paid quite a bit of money just to have the right to do that. So that tells you how highly they thought of our publications. Well, we're sitting in there and they're promoting this one book. It was from American Tech. Well, I told them at the time, I said, it'll take you 3 or 4 books to add on to that book to get what you get out of that design book. And they said, nah, you don't know what you're talking about. So we go back the next year, and to this day, we still have a lot of IEC chapters that use our publications. They won't even use the international. Well, I show up there the next year. Guess what they did? They recommended 3 new books to supplement and add to the publications there. And there were people sitting at the table. They said, wait a minute, Mr. Stalkup was here last year and he said you would do exactly what you're doing right now. And the guy said, I don't even have to sit in this meeting any longer to hear about these other publications. He goes, we're using their publication. We're not using any of these. And that actually happened. There was like 4 or 5 guys got up and just walked out.
Wow.
So is that the what's that? American ATP or something like that?
Yeah, ATP used to publish Dad's publications.
Right.
And that ended up going away because Dad had instructor guides. And those instructor guides were almost like books, especially when you were dealing with the journeyman and masters, because there was all those calculations and everything. They were probably 100 to 150 pages.
They actually approached us, and we just wrote our own book.
Just wrote your own?
There you go.
We wrote our own because I didn't want to own somebody else owning our book.
Yeah. Well, after that happened, Dad wanted the money for those that work that was done, and they told him, we don't pay for instructor guides. And Dad said, oh, yes, you do. And it was a lot of money. I mean, it was a lot of money. And so we had to go to court over it and everything. And what ended up happening, we just ended up canceling the books and everything. And at that point, we had to rewrite everything. So we rewrote all the publications at that point. Wow. And that's the only lawsuit that's ever happened with Gray Boy as far as it relates to publications. Despite what Charles Buckhart says, which is a lie. He says we've been sued for copyright infringement, all this. And I'm like, how? That is a lie. And I said, you show me where it says that. And he couldn't produce it because it never happened.
Right. Well, what's funny is that how do you get copyright infringement from all the material that what you created?
That's right.
It's like your original material.
Yeah, and all we did, we redid all the illustrations, which are way better than what they were in American Texas time. Because back then, we started getting to the point where you had all the computers and everything. We were able with drawing programs, and we redrew everything. My brother did it, and all the material they put together before was hand-drawn illustrations that was done by my brother that they did on I guess back then I don't know what program they used back then, but that's how they did it, was based on his drawings anyway.
Right.
Well, and we do have a little bit of beef against Billy because he pointed accidentally to the neutral and called it a hot. But you know what I mean? It's good old Billy. It's all good, Billy. We got you, brother.
Oh, it is a current carrying conductor, right?
Yeah.
he
Easy
pointed at the
mistake.
phase conductor instead of the ungrounded conductor. We missed it, and I just posted a general illustration, and the boys over at ECD made a big deal out of it, and I was like, yeah. I said he pointed at the wrong one. That's a mistake. I said, yeah, it's wrong, and they were so offended because it pointed at the wrong one, and Bill will tell you there were probably 30 different arrows on that one particular illustration pointing to all kinds of stuff.
Yeah.
And just one got pointed the wrong spot, and they wanted to crucify me for it.
Yeah, that's true. I was there. I witnessed the crucifixion.
Well, remember, nobody talks about a nobody.
Yep.
I actually defended King James numerous times when certain times when texts get deleted and stuff like that, and people don't want to own up when they're trying to call daddy and tell on you.
You know, Mark, what I said?
What's that?
I said, well, I can't check everything. My dad missed that.
That's funny.
Throw them under the bus.
All right, let's wrap this up. I want
All right.
Cars have some wins.
Yeah, right on.
That's right.
No, excellent. Awesome times, guys. I appreciate it.
All right, everybody.
Thank you.
Everybody have a good week. Sign us out.
Remember, make every day an easy day. Peace.
Have a good week, everybody.
Peace.